Everyone, this is Vipin here. Welcome back to my channel. In this video, I'm going to discuss the single tube manometer with incline tube. So this is the single tube incline manometer which you can see on the screen. So in this, you can see that this length R is obviously greater than this vertical height, and the reason behind this keeping this inclined is because the slight changes in pressure also can be observed in a better manner if we take this type of inclination in the tubes. Okay, otherwise there is no other difference. The process of finding out the pressure inside a pipe is again the same. If this is closed here, let's say we are just closing it from this, and then there will not be any atmospheric pressure on this side, and we can simply do the same process which we did in the last video. So we will be applying the principle of hydrostatics at this datum line xx. This original datum line was here. Let me tell you one more time. So because of this pressure PA, there is a reduction in this level in the volume, and this much of red zone is the volume, which is basically equal to the rise in volume in this limb. Okay, so before that, this original line was the equilibrium line of equilibrium. So the level of liquid on here and here was same, but since this has been reduced, this has been compressed because of this, so there is a rise in this limb. Okay, so you can see even with the slight change in pressure, rise is this much, you can see. Okay, so applying the principle of hydrostatics in this, if we take the pressure above xx in left limb, so that is equal to Pa plus, if density of this liquid is rho w into g, this height is r plus h. Okay, so this is the pressure on this side, which is same as the earlier one where there was no inclination in the tube. And in right limb, if we take, so the pressure will be, now here this r sine theta is the distance, the vertical distance. This is the inclined distance, so we will be taking the vertical distance only here. So in right limb, what will be the pressure? So pressure in right limb will be equal to rho m, which is the manometric liquid. So rho m g into r sine theta plus this distance h. Okay, so h is very small value here, so there is no need to take the effect of theta in this, and we can directly add it like this. Okay, so this is equation 1, this is equation 2, so we can quickly equate them, and we will be getting Pa is equal to rho m g r sine theta plus h minus rho w g small r plus h. Okay, and we already know that the relationship between h and r is given by the relationship between this, so that can be applied here also. So that way, uh, this equation, this is the final equation, by the way, because the area relationship between the container and the limb is of the order of a upon a is 100, so that is a generalization. Okay, so it's not necessary it will be 100 always, it might be some other value. Accordingly, we can put the value of h in this. Okay, so h can be basically calculated with the help of this. Okay, so here also h is going to be r upon 100 in this case. Okay, and if we put in this, so Pa is equal to rho m g r sin theta plus h minus this, yeah, r sin theta plus r upon 100 minus rho w g small r plus r upon 100. Okay, so this is the final equation if the area ratio of the container and the limb is 100 times. Otherwise, whatever the area ratio is there, that will be replaced with 100 in this equation. and this is the final equation. So I hope you liked this video. If yes, you can share this with your friends, and please subscribe my channel if you are new to this channel, and if you are already subscribed, please share it as much as you can. Thank you and take care.